let's first briefly introduce myself. My name is Jaap, which is a Dutch name, which is not a coincidence. I'm from the Netherlands. That's that small country at the other end of the world where they have that funny accent of Afrikaans. I'm a Java developer, software architect, and I've been doing Java ever since 2002, professionally since 2006. And in my personal life, I'm a husband, I'm a father of 2 girls, and as you can see in the picture, I like to play board games, not just holding them, but also actually playing them. I work for a company called JStack. We're a bunch of Java and JavaScript developers in the Netherlands and Belgium. We do consultancy, we do internal projects. So. Next up, of course, why this talk? Why am I here talking about Apache Kafka? Well, a few months ago, I was in an assignment where we were looking into introducing Kafka. It sounded interesting, probably would do the job. So I went to some conferences and went to some talks, about plenty talks about Kafka. And they're all good, but they're all about the architecture, about how you apply it, about use cases for it, and that's all interesting. But then I had to start and set up a proof of concept. And I thought, okay, where do I start? I just didn't know, at least not based on these talks. So I did some research, I got it working, and I thought, well, maybe that's worth sharing. So that's actually what you're going to see, my first steps into Kafka, setting up a proof of concept. So brief recap. As I said, it will not be actually about Kafka, but it might be useful to have some background. It's a distributed streaming platform. That's the formal definition that they apply themselves. It's a publish-subscribe mechanism, so you can use it for eventing. You publish and you subscribe to topics. And what you send there and get from there are records. And a record is nothing more than a key value pair. And yes, it has a timestamp, but you get that for free, actually. So it's really low level in what it really does. It's advanced in what you can do with it. So I created a little setup. So let's introduce that first. It's a hypothetical thing, but let's say we have a web shop, and we do have a kind of microservices setup. So we have a payment service to handle our payments, and we have an order service to keep track of orders, and it's all tied together with REST APIs, and we're good, it's okay, but we want more. So what we want is to keep track of inventory. We want to know how much stuff we have in-house that we can still sell. So we want an inventory service. And also, we want to notify our clients about order status and stuff like that. So notification service would do fine as well. So of course, the talk being about Kafka, my solution is introduce a Kafka cluster there. We will be sending updates about the order status that can be picked up about by the inventory service and by the notification service, so they can do their thing by keeping inventory, sending out notifications. Actually, I trimmed it down, so what's in the dotted box, that's what I actually will be doing with you. So I think, yes, it's demo time. So let's briefly first introduce you to my setup. I'm using Docker Compose. And can everyone read this? Yes? Okay, great, thanks. What I have here is a single node Kafka cluster to run on my own machine. As you can see, there's 2 parts of it. It's Zookeeper, that's the cluster manager, and there's the single node Kafka cluster. I called it Kafka Broker because apparently if I call it Kafka, it will introduce some environment variables that Kafka will stumble upon. So that's not really useful. I won't go into details about the configuration. So this is currently running on my local machine, and I will be adding the services to the same Docker Compose network. So let's see. So first thing we need to do is, in the order service, start sending out events that order status changed. That's what we're interested in. So what I have here is, is a really simple setup with Java EE. It's not feature complete, but it will do for the demo. Over here we have our order service. Oh, okay, something went wrong. Sorry. The solution is already in there, so that's giving away some of the fun. I hope this is better. Yeah, this is better. Okay, there we go again. Oh. Come on. Yes. So back to the other service. This is where all the magic happens. Well, it's not a lot of magic, but here information is coming in that's originating from the payment service. So it gets confirmation or rejection on the payment if something failed, the credit card expired or stuff like that. And so this is the place where we actually want to say to other services interested, okay, something changed about the order status. So in order to do that, we need to introduce a little component to do that. So let's first do that and create a little interface that we can use here. Let's call it order status publisher. And I want it to be an interface. And actually, this can do with a single method order status changed. And what we're interested in, what order is it? So I'll give it an order ID, which is a long in my application. And I'll give it the new order status. So okay. So now we have something that we can work with. So I'll add it in here. Order status publisher. And then here we can say, okay, we persisted this, so then we're sure the status has changed. Let's notify orders. I have the order ID already, and I'll get the new status from the order. Okay. Then actually, that's for the confirm part. We also want to do that for the rejected part. So up until now, it's quite basic, but yeah, this needs to go somewhere. We need an implementation for the publisher. So let's create that. Let's create a nice package for the implementation. And create a new class, Kafka order status publisher. Okay. Great. So now what do I do? In order to send something to Kafka, I need a client. So there is, let's see if I can, yeah. In the Kafka client library, there's a class called Kafka producer. And as you can see, it takes two parameters there. which is the key and the value type. Okay, I might be able to use that, I think. So let's see, what do I need to do? There's a send method over here, okay? And that takes a producer record. So let's get started. So let me get a Kafka producer. Key type was long, and I'm not going to the whole way and just make the status a string on the line. So I'll deal with creating that producer later. At least make sure it's injected here. Need to make sure this is picked up as well. So there we go. Let's send something. Okay, it needs a new producer records. Let's see what that takes. As you can see, there's a lot of options, but at least I need to define a topic. And the nice thing is that by default, Kafka will automatically create you a topic. So there's no extra configuration required there. So I can pick whatever I want. So let's make this order status changed. But there's more. So what else do I need? And let's go for the easy one. I want to send a key and a value. As you can see, it also allows you to send just the value. You can leave out the key if that's okay for you. But in this case, I need to have an identifier. So I'll go for the key and the value. So I have my order ID as a key, and the status I want to convert to a string. Let's see. That doesn't belong there. It belongs there. Okay. That's kind of okay, but now my Kafka producer needs to come from somewhere. It doesn't come out of thin air, unfortunately. So I'll create a little factory for that. So I want to, produce something being a Kafka producer, type long string. Okay, then let's create one. So I need to supply some arguments. Let's have a look again. Oh. Okay, first of all, I need some configuration. So I'll deal with the configuration later. Just make a helper method for that. And then what else do I have? Okay, it requires a key serializer and a value serializer, because what you're actually sending are bytes. So I need to tell Kafka, or at least the Kafka client here, how to translate whatever I put in into bytes. Luckily, there's plenty of standard stuff coming along with it. So there's a long serializer. I need that one. And then for the value, I'll supply a string serializer. Okay, great. Now just deal with the configuration. What is it? String objects. And actually, it doesn't really need a lot of configuration by default. You can configure a shitload of things. But what it actually just needs is to know where the cluster is. So this will be, yeah, I'm doing it fine. This will be running in my Docker Compose setup. So it will find it via Kefka broker, and it's running on port 9092. And that's about it. So if all is well, we've got everything covered for sending out events. Let's see if it works. Fingers crossed. Yeah?
Maybe check in the service. I don't think you injected the publisher.
Did it? Did I? Maybe you're right. I just said I would do it. No. Oh, no, I didn't inject it. Okay, great. Thank you. You saved me.
It's the demo box.
I think we had enough of the demo gods before lunch. Still complaining? Not proxyable. Did I miss something there? Oh, dang. Okay, anyone see the error? That's too bad. Let me... Okay. Not proxyable. Did I do anything? Don't have non-private constructors. What did I do? Oh, yeah. Okay. No. That actually is a non-private constructor, is it? It's over here. Okay, this sucks. Sorry for that. Let's see if I can resolve this some other way. Let's do it this way. No changes detected. Okay, this is loads of fun today. What's it doing? Okay.
Change it to singleton CDIV? Maybe it has to do with the scopes of the beam. I'm not sure.
Maybe. Which one? This?
This guy.
This guy? Singleton. No. Well, a no-R constructor. For this one. Might be. I don't think so. But let's try. So. Okay. You saved my ass, I think. Let's make it readable again. So let's build this and let's see if I'm not bullshitting. So that's great. Let's see where I'm at. So let me first build the Docker containers and then let's run it. Okay, we now have the order service up and running at least. And what I have here, if all is well, is a nice script that runs Kafka console consumer. So this will just listen to the topic I created. Okay, hope it's just a warning. Hope I'll be good. It should print here. So then let's go back here. Close this one up. I prepared some REST calls. So first of all, let me show what is in the order service. So there's three orders in, all with a different amount of stuff ordered. Current status is created, and they have an ID and they have a product ID. So, okay, that's simple enough. Now let's see if we can get messages out. So first one here, I will set the payment status to confirmed, which will make the order status, let's see, what was it again? I believe it's also accepted, but we'll see about that. So it's 204, it's great, that's what I expect. Now let's see if we got some output. Confirmed. Sorry, I was mistaken, but at least you see it picked up on this. Now to prove that it wasn't just a coincidence, I will also reject an order. And here, okay, here it says cancelled. So this is the order status. What I'm sending in through the API is the payment status. What's coming out, here is the order status. And actually, it's not really sophisticated, so I can do this again and again just to show you we're getting output. You wouldn't want that in production, of course, but helps for the demo. So okay, that's one part of the issue resolved. Now we need to pick up on these messages in the inventory service. So let's do that. Let's get this out of the way. So we already know we need some Kafka thingy to receive it. So let's create a nice package for that. And let's start with the familiar stuff that we've already kind of seen. Let's create a factory to create a Kefka consumer, which is actually the other side of the solution. So consumer factory. And this is singleton. And here again, I need to specify my key type and my value type. Let's see what we need to do here. Well, it will not come as a big surprise that it's kind of similar. So I need a configuration here. Again, let's postpone that drawer to a little later. And then here, it doesn't need to serialize but deserialize. Well, this is kind of similar again. So I have a long deserializer here and a string deserializer, and we're good with that. So now let's go to the configuration. No. Oh, sorry. String objects. config. And of course, again, I need to tell it where my cluster is. So here too, bootstrap.servers. You may notice it says servers. It actually does client-side load balancing. So it's a single node cluster. I'll just provide one node, but if you have multi-node cluster, you have to provide them all. So Kefka broker. But there's one more thing that I need here, and that's because, well, it's microservices, it's cloud. I might want to end up with more than one instance of my service, and it will be stateless and stuff like that. So actually, I want only one of my instances to consume the message, and not all of them, because that would become a mess. And well, Kafka actually supports that pretty good by saying, okay, you can define a group ID, and you will only have one consumer that will actually consume the message within a group. So let's define a group ID. You can call it anything you want, as long as it's the same for every instance. So since your instance resort from the same code base, it will be easy to keep track of that. So I'll call it inventory, then it makes sense. Okay. So now we've got our consumer. Let's have a look at the API documentation. Let's see where it is. As you see, it's pretty well documented. If you like reading, eat your heart out. It's also useful documentation, so that's good. What we actually need is here is the poll method, and I see it's been deprecated since 2.0, so that's the risk you run when you update your version briefly before you talk. But we'll do it with the deprecated method. So it says poll, and that's because that's actually what you need to do. You need to build a polling mechanism. So it's not as easy as sending something where you say just send. It's not receive. No, you need to poll continuously. And since it's enterprise Java, I don't want to create a for loop with while true or something, or I need to find an enterprising matter to resolve this. So let's find one. And I did my research. Don't worry, I don't need to find that right now. But let's create something that sets that up. So I want, let's see, Kafka initializer. Okay. And I want that to run on startup. So first thing is setting up the polling mechanism to make sure that I don't miss out on anything. And then that's to be a singleton as well. Okay, I do know that I need my Kefka consumer in there. Nope. That wasn't as expected. So. And I'll inject that. There's another thing that I need to make it all happen, and that is it's a long name, so I always have to look at my notes. It's a managed scheduled executor service. It has a method that does the trick for me, and I will show you. So I want this to initialize on startup, so I already made sure it will be picked up on startup. And then I want a post construct So let me make something happen. And it has a method that does exactly what I want. It is the method schedule with fixed delay. I can provide it a runnable that will execute, and then I can tell it to wait for a certain amount of time after that and execute it again. So that comes close to actually doing something continuously, so I'll do that. Let's see, what does it take? Okay, the runnable. We'll postpone that for now. Just say, okay, what will it be? A Kafka poller. We'll create a runnable out of that. Then what else do we have? Initial delay and a delay. So it will wait for some amount of time, and then after every execution, it will also wait for some amount of time. I want this to be continuous, so 0 would be a very sensible choice, but it doesn't accept that. So I'll go for 1. And another 1. And because I want the 1 to be as short as possible, I'll go for the milliseconds. So that's more or less continuously. Good. So that will be executing continuously. But I need to create my runnable that does the actual magic. So let's create a class for that. Okay, it's a runnable. So I need a run method. And okay, I need to pull stuff here. So actually, again here, I need my Kafka consumer. Yeah, that looks fine. Oh, that doesn't look fine. Sorry, well. Yes. Great. So there we go. Pull. Okay. I'll go for the deprecated one. Sorry. So it needs some timeout. Let's take a second. It's just for demo purposes. You can tweak this whatever you like in your production environment, of course. Then what does that give me? Let's see. Okay, so it gives me consumer records. Notice the S at the end. It doesn't give me a single record, it gives me records. And there's a really good reason for that, because Kafka, the Kafka client will do some buffering, and you can use it to subscribe to multiple topics at the same time. So it can be anything. Well, records has a split operator, which allows me to do this. And I now have a stream, and let's see a stream of consumer records. So there's only one left there, so great. Now I want to do something with it. Luckily I foresaw this, so I created an order status listener, which I can use. That will actually pick up the order and process it in the inventory service. So that's already done. So now just use that then. So order status listener. Okay. So and it has a method order status changed, and it takes the order ID and the status. So I need to get these from the record I have. So it's actually, oh, sorry, it's a lambda. I'm forgetting something here. Needs to know what it's called. So just get me the key, and get me the value, but I want that to be an order status again. Oh. Okay. Thank you. Okay, so cool. This will definitely do some stuff, but there's some small parts missing here. First of all, if anything fails here, it will fail silently. I don't want that, because then we'll have the awkward situation again that I'll be looking for a bug and don't know where it is. So I will do something that's not production worthy, but will help me out here to get something out of it. Just catch everything and print it to the console. So you need to do some kind of error resolution here. And I'm pretty certain I missed something else out. Oh yeah, sure, I didn't subscribe to anything yet. So, oh, sorry. Let's go back to the initializer. It knows by now it's missing some arguments also, so given this is the bean, let's inject the order status listener here. Okay, but yeah, before I start listening to something, I need to tell it what I want to listen to. So Kefka consumer, subscribe. And as you can see, as I thought, you can subscribe to multiple topics. So it requires a collection of topics. I only have one, so I'll create a singleton collection, and it was called whoa, yeah. Status changed. Good. So let me check before I fail again. If I had everything, yes, I think so. Yes.
Your consumer factory still had to add the producer's annotation.
Probably, yeah. Oh, you're so good. Thanks. Thanks. Yep, there. Thanks. Good. I'm slightly confident this time. So let's run the show again. I need this one. So let's build the inventory service and go back to here. First, stop everything. I wasn't anywhere without you. Imagine this talk would be without audience. It would be awful. Maybe it is right now, but at least we're getting through the demo. So let's build some new containers. Good there, and run the show again. Now it's in-memory repository that I set up, so all order status is restored to what it was, which is good because I actually need that for my demo. Let's make some room. So as a quick reminder, these are the orders that are in the system. Now I can start querying the inventory service. As you can see, I can do that by product. So let's see, product 101. It will say, okay, total of 1,000. As you saw by the orders, there was an order for 20, so there's 980 actually available to sell to other customers. And here for 102, I'll show that as well. So there's 950 available. So now, if I now reject order number 2, which was for product 102, that should mean that my availability should go back to 1000. So let's see. Okay, this part did the job. Now, and there it is. Okay, you need some more proof, I guess. So I also logged the new status. It's down here. Okay, great. So we got it working. And as you saw, it was quite a lot of boilerplate I need to do to get something as low level as this running. And it's okay. So when I did this, I actually created a little helper library out of that with some annotations that I could tag on methods on change annotation. So the events got distributed and injected, and that's very nice, but it takes a lot of time and it takes maintenance. And there's actually frameworks out there that will help you with this. So I want to redo the inventory service with you, but this time it will be a Spring application, a Spring Boot application. So let's go back. As you see, I prepared it a little bit. It's more or less the same stuff, but the setup is completely different. So Spring Boot will give you a lot of stuff out of the box, but it does need some configuration. Here I actually have a proper configuration file. So let's get my configuration in there. As you can see, it more or less translates one-on-one with the configuration parameters that you need. So the bootstrap service, broker, and of course we also need the group ID. Let's call it inventory again. And there's one more thing I need to do now, because as I said, Spring Boot will assume a lot of stuff for you. So one thing it assumes that both your key and your value are string, but I have a long key. So I really need to override here that, there it is. My key deserializer is not a string deserializer, but actually a long deserializer. You need to define the fully qualified name here, but luckily I'm using IntelliJ that can help me. There we go. So that's the configuration I need. Then, as I said, I myself created a little library with annotations and stuff. And the fun thing was, when I started looking into Spring Kafka, I came to the realization these guys did the exact same thing. So it was kind of relief for me. I wasn't really doing stupid stuff. I was doing just stupid by doing it myself. That's the only difference. So now let's directly go to the order status listener. And this is actually the method that does the magic. So let's annotate that. I want it to be a Kefka listener, and I want it to listen to these topics. Order status changed. And then I also need to define how it has to subtract the values from there. So I need to say here, this is a header. As you can see, it's reusing annotations from other Spring projects. Only here, it is Kafka specific. So I can now say Kafka headers dot receive message key. So that will say, okay, the key is what you need to inject for the order ID. And here I can just say payload, just like with the other messaging solutions of Spring. And it will see, okay, there's a string coming in, this is an enum, I need to convert that to an enum. I didn't need to resort that all myself. And that actually is all I need to do to get this working with Spring. So let's see. First, turn this all off. Oh, need to do my mainframe build first. So, build success. There we go. Fingers crossed. There we go. Oh, error. That's too bad. Still something running. Yeah, still a lot running. Let's first kill this. What do I have left? So that's Kafka, that's fine. Okay, should be fine here. That's looking way better. Great. Okay. Now I should be able to do the same demo again. So let's see. As I said, it's all in memory, so I'm back to my initial state, which is good for this time only. And let's cancel another one and see if it really works out. As you can see, again, it was successfully cancelled. So what I wanted to show, especially with this last demo, is that you can do all the low-level stuff with Kafka, and you can get even more low-level if you want. You can knock yourselves out with configuration and stuff. But if there is a sensible option for you to pick a framework that takes away all that boilerplate stuff that you need to maintain for yourself, I would do it. And that really brings me to the end of my talk.